Literally nothing is really, really good in Kotlin. Of course, I am talking about my favorite feature in Kotlin's type system called nothing. You probably know that every type has to be a subtype of any or any question mark if we include nullability. However, the nothing type is special. It's called a bottom type, and beautifully enough, it's the opposite of any question mark. It can never exist. It's nothing. But what does it mean to be the opposite of any question mark? When every type has to implement any question mark in Kotlin, then in order to be the opposite of any question mark, nothing has to be a subtype of every other possible type in Kotlin. And that's exactly what it is. Let me demonstrate this straight in the IDE. Let's say we have a function that we never ever can return. We call it never. We say that it's just looping forever. It cannot return. This function will return us nothing, and the compiler here is happy to accept this return type. Let's say we have another function which expects to return a string. Let's call it function foo. It returns string, and we can see that, of course, we can just return an empty string here. However, we are also allowed to just return never. This happens because nothing is a subtype of string. This would also work if it is int or any type that you can create yourself. So let's create this type foo here, request it as a return type in the small function foo, and you can see the compiler is happy to accept never as a valid return type of foo. But the real magic happens once we bring generics into the picture. Let's say we create our own result type. We call it our result. And we, of course, make it generic. We say it's a sealed class, and we have the obvious candidates. We want to have a result that is successful, and we want to model the failure case. Therefore, we have data class success, which carries value t, and it implements our result of t. And we also want to have an error class, which is also generic type parameter t here, which also implements our result t, and it can contain some kind of throwable that represents what happened. But looking at our error class here, we notice that this type parameter t here is not necessary at all. We just carry a throwable question mark error. There is no need to know anything about this t. So we are free to remove it from our error here, and we can say that this is an our result of nothing. There will never be a value. It cannot give you something, therefore it is nothing. Let's try this in action. Let's say we want to have a function foo here, which returns us a string. And we remove this function never, and we replace it by something that is like a HTTP request, which returns us either string on success cases or some throwable or some reason why something did not work. So it's an our result of string. And we can return, like, for example, our result success here. And of course, we can return this HTTP request and unwrap the value. However, if we look at the code after we unwrapped the result, we see that we get an error from the compiler, which says something about incompatible types. We expect that our result of type string is coming back, and we cannot just cast it to our result of error. And the reason is because our result of error will be our result of nothing, which is not exactly the same type of our result of string, right? We need to tell this our result something about its variance. Right now, it is invariant in t, meaning when we expect some type like our result of string, we want an our result of string and exactly our result of string. Our result of nothing, despite nothing, subtyping string is not okay. We need to tell that it is okay to accept subtypes of this t to be valid here. As a rule of thumb, because in Kotlin we have in and out as modifiers for co and contravariance, my rule of thumb is if you get something out of this class, like you can read this value, you get it out, then it's covariant, you use the out modifier. If you pass stuff into this class, let's say you have a function and you pass some value of type t into this function, you use contravariance and you use the in keyword. So now that we marked this class to be covariant with this type parameter t, it is now happy to accept that, yes, our result of nothing is a valid representation of our result of string, and it is able to unwrap it here, and we can just access this result.error.message. However, there's even one more cool party trick that I want to show you. It is now with inline classes and this kind of variances. Let me show you how we would write a value or function. Let's say we want to have a generic function value or on our result of t, and we say that it either unwraps it or you provide me some alternative. This alternative function will get past our result of error, and it has to provide me the value t. So we unwrap it here as well. We call alternative on this to provide the alternative value of t in case it is an error. And now the real cool magic happens once I also mark this function as inline. Let's say I want to use those function in an arbitrary main. I can then just call this HTTP request, and I can unwrap it now using our value or function. And I can say like HTTP response equals HTTP request, value or, and now here the real party trick happens. I can just say that it should return, and it will return since it's an inline function straight out of the main function. And if you look into this HTTP response type, it is a string. And the beauty here is that not only functions that really never return something like forever looping on a while loop, but also functions like the error method or throwing an exception or the return keyword, they are treated as evaluating to nothing. They will never give you a value. Therefore, the return type is nothing. And this value or alternative closure that I have here, lambda that I provide, which just returns out of main, it will be evaluated as a type of nothing, which is a subtype of string. Therefore, it's valid to pass it as alternative to something that returns string. And you can see that in this HTTP response, I can just access this length. I can just print it to the console. And here you go. Nothing is really, really cool in Kotlin.